Hi everybody, my name is Jonathan Hennon. I'm the coordinator of Topic 3 as part of 263 Environmental Science. My topic is Introduction to Zero Waste Management, and this lecture will be covering global waste issues, background, progress to date, theory, practice and disposal technologies, and then in contrast of that we'll be looking at zero waste in a circular economy and discussing the difference between those world views. So first and foremost, I'd just like to welcome you all to this topic and introduce the written resources that are on stream. So there's six sections to this, and these are pretty comprehensive, and there's a lot of information there. There's also supplementary readings. In the written resources, I'd like to highlight that there are thought-provoker questions, which my encouragement is that you utilise and develop some bullet points answers. And my hot tip for this topic is that that will equate to some really good exam preparation, but also some really good structured learning in terms of coming to grips with all of the information on offer in this module. Now, the key bit of information that I need to outline is that due to the COVID-19 situation, I've made a tactical decision based on guidance from the university to shift into distance mode. The reason we're doing that early is that rather than have to do that halfway through the module, which would be disruptive, as part of those responses to the COVID situation, I also unfortunately had to cancel the laboratory sessions, which were field trips, which I had planned. And I will shift from original three lectures into 6 lectures, which I will aim to kind of create, I guess, a version of the learning that we would have encountered through the field trips, which would have been engaged with the PAMI Plastic Pollution Challenge. So hopefully you won't miss out on too much. Now, so this is the amended lecture schedule for the next three weeks, which carries over past the mid-semester break. So on this basis, I'll be delivering 6 lectures and also setting up a Zoom meeting time, which would be 4:30 p.m. in the second half of what would have been the 2-hour lab slot. So this is an opportunity for us to gather online, for me to address any questions or queries or issues, and certainly to discuss the learning that's on offer. So essentially this puts internal students and distant students and students who are locked out of New Zealand all in the same platform. As I said, unfortunately we're missing out on some of the opportunities we would have had with doing some practical learning out in the field, but hopefully you'll be able to capture some of that. Now, what I would say in terms of all of this is the lectures that I deliver are covering a whole lot of material, and I've also created a rich learning resource in terms of the written materials. So there's just truckloads of information that you'll need in terms of navigating how you deal with the assessments and any amended exam assignment sort of situation in terms of the possibility that we won't be able to have an exam. So this is going to be an ongoing situation. I'm certainly doing my best to adapt to this using this technology, so hopefully that will go well. But what I would say is that please feedback to me directly, and this is a flexible scenario. We're in this together, so if you've got some ideas on what I need to do differently, I'm very happy to talk with you about those. I'd also like to welcome the students from 188707, Advanced Environmental Management postgrad class, that are joining into this module as well. So onwards and upwards. Okay, so what do we do with waste? Well, historically, we have done a whole bunch of different things with waste. We've got images here which illustrate incineration at sea, open sea dumping, of course landfills, incineration on land, and then it needs to be recognised that so much of what we call waste material actually escapes collection and management systems altogether, and that's creating a global crisis. And there's also another element, and the bottom right image is one of several thousand drums of hazardous waste that was illegally dumped in the ocean, is that there's actually an organised criminal element involved in waste management, and this is, obviously highly problematic. This next slide again just captures a compilation of images of what's happening in the world of waste, and which is just causing us a whole lot of questions. And I guess in that context, concepts like zero waste and the circular economy arise in response to what are now recognised as pretty much a widely recognised global crisis in terms of how we're managing waste. So I firstly want to just give you a little thumbnail of how well global waste management is working. This slide here, I call this my iceberg slide, is a little bit dated now, but it illustrates quite usefully how on a resource basis, each of these are different resource types. Above the line is what is recovered and recycled. Below the line is what is disposed. So if on various types of resources, the vast majority are not being captured and reused, and the value being maintained within the economy. So, sorry, I'll just take that back a little bit. And then just in the bottom right-hand corner is what we would call the ubiquitous, agreed theory of waste, conventional waste management anyway, about what our priorities should be, with the main priority being reducing waste, reusing waste, recycling, the so-called 3Rs, and supposedly our least and last priority is disposal. In reality, what we need to recognise is that by default, most waste is actually, this waste hierarchy is shaped this way, and most waste is just being disposed of or being recovered in terms of waste to energy and incineration scenarios, which is essentially about destroy the value of those resources. So after 40 years of having an agreed idea with the waste hierarchy of what we're supposed to be doing, in reality, we're not doing that. That's in spite of actually spending literally trillions of dollars over the last decades aiming to achieve this. So this next data just illustrates that in a little bit more detail. The top priority is to reduce waste. So the World Bank estimates that in 2002, globally we're producing 0.68 billion tonnes, 2012, 1.3 billion tonnes, and by 2025 estimated at 2.2 billion tonnes. Because of population growth and increasing consumption and urbanisation, waste generation rates are projected to more than double over the next 20 years, especially in low-income countries. And without aggressive sustainability scenarios, global peak waste is not projected potentially until 2100. So all of the challenges we have now are just, in a sense, a glimpse of what the future holds. So we're not achieving our top priority, which is to reduce waste. What's happening at the bottom priority? So a project looking at global waste data, the D-Waste project, looked at a variety of different considerations, and they reckoned that 3.5 billion people, or 52% of the global population, lack the most elementary waste management services. So even though the bulk of material is being disposed, the bulk of people in the world actually don't even have access to the most basic waste management services. And even when those baseline services are in place, there's a whole lot of issues around social justice as well as environmental pollution. So we're not even at the 50% point of getting the global population engaged in basic waste management theory. So what about recycling? So some data produced estimated that total waste is total waste, including municipal solid waste, which was included in the previous data, construction and industry and, commercial industry and construction demolition, currently 3.4 to 4 billion tonnes. Just another point is that actually that's in terms of their products that are in the economy. These guys, McDonough and Braungart, talk about the concept that 5%, the product actually contains only 5% of the raw materials involved in making and delivering it. So overall, the waste could be much, much higher. That's a little bit of an aside. But of this 3.4 billion tonnes, currently only a quarter is recovered and recycled, a third, depending on how you look at that data. And of the another set of data, the D-Waste project, of the waste produced globally, 19% goes to recycling or mechanical biological treatment, 11% is combusted, 70% is dumped or landfilled. Other research findings suggest that 41% of the total waste generated is estimated to be treated via uncontrolled burning and dumping. So again, we're not even close to being at the midpoint of achieving our middle priority, which is recycling. Now, these creates a whole lot of issues, and the financial cost per capita of waste disposal and trying to do things is enormously higher than actually getting this right. So that's some of the projections in terms of different conversations around the issue of waste. In terms of waste, what I hope to try and communicate via this slide is that waste is an immensely complex scenario. It involves all kinds of materials flowing through the economy, including the built environment. So we just talk about the future of climate change and the increasing incidence of severe weather events, disaster waste management, electronic waste management, pharmaceuticals. Most of the pharmaceuticals in the world, the default treatment is flushing them down the toilet, which disperses them into the environment. I'm sure you've heard about global ocean plastics. There's a whole new future series of waste issues in terms of nanotechnologies. And of course, food waste has been in the headlines as well. So here's a few research perspectives. The interrelated aquatic and atmospheric impacts of anthropogenic terrestrially generated waste is now recognised as affecting the entire biosphere. Globally, waste issues are rising to the point of becoming a public and environmental health emergency, warranting an urgent and comprehensive response. The point I'd like to make is that this is not just the Greenies saying this. Some of those writers are associated with the International Solid Waste Association. So even the mainstream waste industry is now recognizing that we have enormous problems. And this is a report from the International Solid Waste Association, recognizing that our oceans are actually already the biggest dump site for millions of tons of used plastic per year. This slide is from your written resources, and it's a table which just outlines all of these, well, not all of them, but some of the dimensions of the complex waste, global waste issues. Now, a point that's interesting to make is that, that up there, is this writer here, who's a Pulitzer Prize winning journalist. Waste connects to everything: energy, pollution, food, water, health, politics, climate, economics, trash. Trash is nothing less than the ultimate lens of our private lives, our priorities, our failings, our secrets, and our hubris. I love that quote. What it illustrates is that waste is actually integrated with everything we do, in particular, our response to sustainable development and climate change. Waste is the result of inadequate thinking compounded by outmoded so-called flame, flush and fling management approaches, which both contribute to and evidence the fundamental unsustainability of the way our global economy is currently engineered. Waste is the result of a so-called take-make-waste socio-economic design setting of the modern globalized economy, aka the throwaway society. And that's a very deliberate construction that was put in place in the post-war era in order to shift the global economy out of depression and the wartime austerity. And the challenge we face today is how do we reconstruct that lineal flow of materials, the throwaway idea, the consequence-free way of living, to the environmental and economic realities that we now experience. Unless waste is non-toxic, biodegradable, and able to be recovered and assimilated as a technical nutrient or material feedstock for cyclical economic or biological systems, it can be viewed as a simultaneous failure of production, of product production, and socio-economic design. So these writers are drawing on industrial ecology theory, and what I guess would like to point out to you is that whilst waste is fundamentally a massive failure in terms of the production of it and the management of it, it also is a massive point of opportunity. waste is a critical barrier and conversely an enormous opportunity to progressing towards sustainable development. And I'm going to evidence that and talk to that point a little bit more as we go through the teaching modules associated with topic 3. So there is now a global set of actions in play and underway in order to try and address this issue, in particular the Global Waste Management Outlook report, published in 2016, established the goal of 100% collection, elimination, and eliminating burning and open dumps. So that's a fundamental thing to address the fact that most of the global population, in particular in developing countries, don't have any waste management system at all, or it's fundamentally flawed or unavailable. Now, they've projected that if we were to do this, and this resonates with my point about waste being also a massive opportunity for us as a global community, if we were to achieve this goal, they have projected that it would reduce global greenhouse gas emissions by 15 to 20%. It would reduce the 1.3 billion tonnes of food waste per year, which is enough to eliminate food poverty 2 times over. It would create an estimated 9 to 25 million green jobs, and it would achieve approximately 50% of the UN Sustainable Development Goals. So addressing waste problems, and these are just the most basic ones, it's not really about engineering a circular economy, it's just getting most of the global population onto the bottom rung of the solid waste hierarchy, if you like. Proper collection, eliminating open burning and all the toxicity and pollution associated with that, and eliminating open dumps, which actually often are actually rivers and mean plastic ends up in the ocean. Now, they've projected the cost of doing that relative to the cost of not doing that. And so the cost to society of achieving that goal is projected as exceeding the financial cost per capita of proper waste management by a factor of 5 to 10. So essentially what they're saying is that if we do nothing, it's going to cost us so much more than actually properly focusing on getting the global waste management emergency under control and resolved and get us heading in the right direction. Okay, so we're going to step back now and just look in terms of a chronology of waste. The key point is that waste has always been with us. If you can go through some of the histories of this points, 3,000 years ago, before Christ, the first ever landfill was recorded. Thousands of years ago, composting was a very normal part, in particular, of human waste and a part of the food cycle in China, as is scrap metal. So both waste and recycling, i.e. the environmental ways of addressing this, are fundamentally being part of human society. Yet, as society has changed through to the Second World War, where there's been times of enormous austerity, and so everything was recycled. My parents' generation in particular were very, very frugal. And then in that post-war area, we began to produce a whole lot of, for example, nuclear waste, but also organic chemistry exploded and created a whole lot of chemicals, which are enormously toxic, which didn't exist in the, previously. So through this chronology, you see the development of laws and regulations, people involved in recycling. These guys here, job descriptions, toshers, mudlarks, dustmen, they're all part of our vernacular in terms of recycling. We see the first incinerator built in 1874 and the formation of the waste industry. And then onwards, this whole, in the post-war years, the whole development of this lineal throwaway society where consumption and disposability of materials and goods was seen as the way to generate prosperity and well-being. And in many respects, that's correct. It's just obviously has this massive downside. So I just want to point out one of the really good resources around waste management is the Story of Stuff website. So please take some time to look at that. So what's changed? What's different about the materials we use today? And can we ask the question, actually, did we live in a zero waste society previously? So waste was just conventionally thrown out, but because we didn't have plastic waste, the whole issue of waste was a lot more, a lot less complex. This slide here is actually in my hometown in Masterton, where for a period of time in the 1940s, I wasn't born then, but I recovered these photos from the archive. The entire municipal waste was ground up and turned into compost. So this is pre-plastic. We didn't have all these toxic chemicals that we have to deal with today. So this almost like it, indicates we should ask this question. Did we actually have a zero waste society? And obviously, one of the key challenges that we face today is the ubiquity of plastics. Plastics, in one sense, can be regarded by some people as a miracle material, but as you can indicate, in these slides here, plastic where there's no waste management systems is just a massive issue for us. This slide here, again, is in the written resources and just characterises the historic characterisation of society, where we had non-toxic materials that were dispersed, small volumes, through to everything was done, frugality happened in a household, often recycling happened within a household. We lived in small agrarian societies. There was a much stronger religious and cultural ethos around what you did and didn't do, right through to the modern characteristics of society. So I just encourage you to have a look and have a think about that, and think about the way things have changed in our modern society, and what do we need to do differently in order to get ourselves out of the scenario that we're in terms of a global waste crisis. Just taking a bit of time to think about the primary ways that we address waste management issues. So this is a schematic of a modern landfill. Now, a modern landfill is not an open dump. It's not a swamp where stuff gets put, but that's how it all started. So landfilling now is obviously quite a highly engineered structure, and are pretty well regulated in New Zealand. The cost of landfilling has gone up exponentially, but it wasn't always that way. For example, our landfill in Palmerston City, only a very small latter proportion of it was properly encapsulated with a proper liner, geotextile liner and a clay liner, and then properly capped and looked after, and extracting the methane that's generated from that to generate electricity. The majority of landfills globally are pretty rudimentary, but it's important to recognise that we can engineer landfilling to make it more environmentally acceptable. Incineration, again, is another major way of addressing dealing with waste. To a certain extent, it reduces the volume a lot, and there's a lot of debate around the value of incineration. So this, and some people regard incinerators, there's some incinerators, they're kind of beautified and made into amazing places, but fundamentally incineration is about burning resources, and you can extract energy from that, but that doesn't get you away from the fact that you're burning those resources, and then they have to be extracted from the natural environment at some point. So there's a whole lot of complexity around alternative waste technologies, and the way that we can extract value from waste. And this is a space of red hot debate. So there's some information about this in the written resources, and you can just see this schematic here from Zero Waste South Australia in Adelaide, where they developed some resources sort of going through some of the debates, the thermal processing, biochemical processing, and chemical recycling around how you can extract value from existing resources. This is a schematic of a basic incinerator where there's energy recapture. The trucks come in, the material is incinerated, some heat energy is captured, can be converted into steam, can be converted into electricity. But there is a lot of issues around both the ash material, which can be quite toxic, as well as the emissions, scrubbing out the toxicity from the emissions from these things. So this is a space of red hot debate. There are various versions. I'm not an engineering expert on incineration, but I do, I guess from a zero waste point of view, sit back and think about some of the controversy in this space. And there's some really good resources. These are cited in the references of the written resources, and there's some very strong pro and contra debate around this. This is not going away. Landfills are not great, incinerators are not great, but as you can see, most of what we do conventionally is in the disposal space. We're not really thinking about how we could engineer our economy and reduce waste at source, or be really, really creative with our recycling, or really assertive with our recycling technologies. And that's part of the reason is that there's commercial imperatives at the stake. The global waste management industry is invested heavily in these disposal technologies, and they require a return on their investment, and they require maintaining the status quo. So this is a very controversial space, but I'd ask you to really think in the course of this module about what's really green and what isn't green. Again, this just talking about the sort of juxtaposition of our supposed hierarchy of what we're supposed to be doing, which is preventing or reducing waste, versus what we do most of, which is actually disposal of waste. And some people, some parts of the world, this is an illustration across Europe, I think I think it's across Europe, where, this is a little bit dated now, but it just illustrates the point that in the purple is recycling, the green is composting, brown is landfill, and red is incineration or waste energy. So some countries, and this is part of this contemporary debate, have almost eliminated landfill. But the question is, what is happening with all of these resources that are being incinerated? So this is part of the contextual debate. Is zero waste to landfill the same as zero waste as a theory and set of practice? So there's a lot to think about. We'll be discussing that. Fundamentally, oh, sorry. Where am I? Fundamentally, though, when you bury resources in the ground, or when you burn them, essentially what I would encourage you to think is that you're burning money and you're burning jobs, and you're actually creating a massive new debt on the environment, because those resources are all extracted from the environment, so they have to come from somewhere. The zero waste ethos and a circular economy ethos is really about conceptualizing waste as what it really is. Often we don't see waste until it's in this format here, where it's disgusting, it's all mixed in together, it's a problem that we want to get rid of so it doesn't cause disease or what have you, and we can rush to these disposal scenarios. But in reality, that material, if you break it all down, is actually a whole set of resources. It's not waste until it's wasted. So the re-engineering of our society is a fundamental thing. And these resources have all come from the environment. They're actually very valuable resources. And that if we want to reduce emissions and environmental burden on the planet, then we need to think very carefully about how we separate this out. And that means changing the nature of responsibility within the community. So this is, again, this waste hierarchy, but it's reconceptualized in terms of a zero waste ethos. So there's a lot going on here. There's a lot to think about, but from a very simple point of view, this is a version of the waste hierarchy that I'm involved in developing in terms of my PhD research. We have a lot more going on in this sort of cognitive domain, rethinking the whole concept of ownership of waste, reinventing life cycle and supply chains, redesigning products, the whole concept of the way we work, redistributing responsibility, recreating, and then a zero waste concept is basically to get to the point where we're saying that, I'm sorry about this, I'm not managing these, oops, cancel. I'll just go back. Hang on, what's going on? Back to eliminating what happens in terms of this whole anti-burn, anti-bury approach, reforming the way we do landfill and reforming everything. So these concepts, zero waste concepts, are really just, I guess, challenging our way of thinking first and foremost about what we do with materials. And this is some research I like to quote which looked at the best disposal option for leftovers on the way to a zero waste society. They used a life cycle management approach and introduced this idea of material recovery and biological treatment, like basically aiming to extract mechanically as much value and eliminate the need for incineration and waste energy. So the result of this research is that mechanical recovery and biological treatment equals the best environmental practice for leftovers or discarded material, waste material that's not able to be recycled. It recovers, maximizes recycling, removes and stabilizes organic matter, reduces landfill volume and negative environmental and public health impacts. And the conclusion of these guys' research is that waste to energy is not a substitution for zero waste. It's not a pathway to zero waste, that there are still better options. So I want to take a step now and just look at the fundamental definition of waste. This is from a well-regarded textbook. It's about 3 inches thick. Solid waste are all waste arising from animal, human activities, normally solid, and are discarded as useless or unwanted. But because of their intrinsic properties, discarded waste materials are often reusable and may be considered a resource in another setting. So if that's a formal definition of waste, what does that tell us? Well, it tells us that the distinction between something being a waste or a resource is an entirely subjective human value judgment. This designation is based on socially constructed individual and collective perceptions, such as around hygiene, perceived and actual value, ethical norms, infrastructure, the ability to do something different, i.e. infrastructure and technology, time, location, monitoring and compliance. So we can engineer a zero waste society if we choose to. When we think, this is from, this is a commonly often used pie charts to illustrate what is in the waste material. And this slide just illustrates that actually when you separate out all of these materials, you come up and realize that there's clean aggregates, there's a whole lot of resources like tires or timber. There's definitely a hazardous spectrum within the what material is produced. I estimate it's in that 5 to 10%. And that's where product stewardship, which is something we're going to talk about in the future of this course, comes into play. A whole bunch of material is organic waste, a lot of it is recyclable, and then there's a whole variety of other different materials. So just, sorry about this. Okay, so this is a common quote that's associated with zero waste. The point, I guess the point we'd like to make in this slide is when we shift away from that dumb, dirty idea that dominates conventional waste management thinking, the world actually becomes quite a creative space. If we are involved in solving waste problems, there's a whole lot of opportunity for us to re-engineer our society. And I've been part of the zero waste community in New Zealand for 25 odd years, and I regard it as a highly creative and ethical space. There's lots and lots of innovation. This, what I'm just hoping to capture in this slide. A common rhetoric in zero waste is nature is a zero waste system. Nature recycles everything. Why do we find it so hard to follow such a good example? This quote, I guess, challenges us to think about the way the human economy is engineered, and is it fundamentally at odds with the design ethos that the environment offers us? If you think about a forest ecosystem, again, nothing is wasted. The detritus from one life form becomes the feedstock for another life form, and the nutrients are cycled. So that's part of the conceptual model of zero waste in the circular economy. Just introducing this concept, this work is by Review of Sustainability Terms and Their Definitions by Glavick and Luckman. And what it kind of illustrates to us is that there's this whole push in terms of engineering sustainability into the way we do things. There's a massive investment, what I call a complex and vibrant, dynamic eco-ideas marketplace. And in amongst that is zero waste. It's part of what we're doing as a society. The other thing I want to do is align zero waste with industrial ecology and circular economy and things like that, because they're all similar ethos. They have an underlying alignment in this ecosystem metaphor. Nature's a zero waste system, nature recycles everything. Why don't we do that? These guys are circular economy writers, the often founders of the circular economy movement, and nature operates according to a system of nutrients and metabolism where there is no such thing as waste. One of the most important concepts in industrial ecology is that, like the biological system, it rejects the concept of waste. Industrial ecology seeks to loop the technosphere back onto itself and achieve the ultimate industrial ecology goal of zero waste. Even the International Solid Waste Association kind of appropriates the idea and the conception and the language of zero waste, and their vision is to work towards an earth where no waste exists. There's a few kind of issues around the competitive push and shove of this. The UNEP identifies zero waste as a continuum of aspiration responding to the never-ending nature of waste management tasks. So recognition that there will always be a need for improvement, and that once one target has been achieved, others more demanding, more difficult, still remain to be tackled. And that's what zero waste does, in a sense. Zero waste is not an endpoint, it's an aspiration that challenges us to really think about the way we think about waste, and challenges the design of our socio-economic system, the global economy and the local economy, to shift from a dumb, dirty mode into something that's genuinely sustainable. So here we are. This is this take, make, waste lineal economic model. Raw materials are extracted from the earth. They're refined at great engineering and energy expenditure. They're manufactured into goods. Often this consumption cycle is very short and getting shorter as planned obsolescence is built into products. And then we have this flame, flush or fling approach, burn or bury approach. This is the basis of the linear economy. What I'd say to you is that this cannot work. It's just not going to work. It's completely at odds with a finite planet, and we are well past actually the point of needing to address this. What's a circular economy look like? Well, it looks like personal responsibility exercised at an individual and a family. We need to change our sense of what we do. Often recycling comes in and we go, oh, nanny state telling us what to do. Well, actually, if we want to live on this planet, we need to change the way we perceive personal responsibility. It involves collection and recycling, municipal recycling facilities, and there's a whole lot of technology and investment going into improving those. As I said, once we separate all of these resource streams out, they're actually worth a lot of money and they can be reused. Now, there are major issues in terms of global recycling right now, but that's something I want to talk about a little bit separately. That's to do with our failure to invest in local circular economy and building up recycling markets. So again, that's part of the design failure. And then we remarket, and you can reintroduce these resources back into the economy here and therefore not have to extract more from the earth. Another key thing to think about is the reuse economy, the recycling economy. In New Zealand, I'm not sure if you live near a resource recovery centre, but there's some amazing people doing amazing things that that involve the reuse economy, and stuff that we chuck out can be reused by other people. So it's really, I'm going to talk a little bit about that part of the economy later on. So the key thing to understand here is that zero waste, industrial ecology, and these kind of green sustainable waste management movements, circular economy, aim to confront and redesign and replace exploitative lineal, aka take, make, waste, or take, make, dispose, economic settings with progressively circular, more sustainable resource management, understanding waste for what it is resources. Industrial ecology seek to achieve sustainable management of resources by providing a rigorous scientific framework in tandem with a practical approach, which operationalizes sustainability and economic feasibility, so an economically feasible way. I think there's actually things that zero waste, industrial ecology, and circular economy offer each other as kind of aligned strands of imperative in addressing waste issues. The circular economy is described as being an industrial system which is restorative or regenerative by intention and design. It replaces end-of-life concept with restoration and shifts um, towards the use of renewable energy, eliminates the use of toxic chemicals which impair reuse, and aims for the elimination of waste through superior design of materials, products, systems within their business models. This is a view of an industrial ecology view of the planet. And it's got a research basis, and here in the center is what they call the anthroposphere, the human part of the atmosphere, hydrosphere, the geosphere, and the biosphere, the global kind of uh, the planet that we live in. And this graphic is quite useful because it illustrates how we exchange of materials and energy within that. And we can conceptualize human cities, human society as part of that, rather than kind of independent of that. And this is, I think, really important because we now understand, because of climate change, is that human society, what we're doing is influencing we're actually adjusting what's happening in the whole biosphere, the whole planetary biosphere, and causing problems not just to the planet but to ourselves. So we're in this scenario where this kind of conceptual understanding needs to be mainstream, and we need to kind of understand the role of human society in the planetary ecology, and make adjustments so that we become sustainable and we're not a destructive part of this, which we depend on. This is another way of looking at that, the anthroposphere, or the technosphere as it's called, the human component of that. Everything we get for our human economy is drawn from this, the source, planet, and when we emit or waste, it goes back into the planet. So we're living in the midst of this take, make, waste conundrum, and we mine, we extract, we refine, we manufacture, and then we potentially can do this. So this circular economy, zero waste idea recognizes that as we extract materials, we increase the demand, the drawdown on the natural environment, and we also increase our energy emissions and the pollution generated. So we're using a whole lot of energy. And then if we can re-engineer our society, our technology, our economics, our politics, our legislation, our social conception of how we work as a society, these ideas, we can realize the true priorities of the waste hierarchy and actually put them into place. We can reduce, we can reuse, and we can recycle, and we can eliminate some of this burden. This is nearly my final slide, because in the next lecture, Sarah, the next lecture, we're going to be talking about plastic pollution. Now, this is fundamentally, I want to introduce the concept that waste is not just a technical problem. This slide captures the work of a group of, I think, Taiwanese or Korean arts students that were looking at this concept of plastic pollution, the ubiquity of plastic pollution. They produced this as an art form, as an artwork. And I think it's a really, really compelling piece of art, but it challenges us, I think, to think about what we are giving our children in terms of their future, and it puts that into a really nice conceptual model. But it also, I think, challenges us to think about waste issues as not a technical thing. We don't need another big black technical box that we chuck waste into to make it go away and to fix the problem. Waste is very much about what's happening up here, our social conception as a human community. So this is almost my last slide, and I just want to introduce that in the next lecture, we're going to be talking about a local project, looking at plastic pollution. This is what we would have studied and examined in our field trips, but we're going to do that on an online basis. I hope you've enjoyed the lecture. I hope it's stimulated a lot of questions, and in the online Zoom meeting slots, we can meet and we can talk about that and make the most of our learning construct in spite of the limitations that are imposed on by the COVID scenario. this recording is going to be loaded into Stream. The slides are going to be loaded into Stream. So hopefully that will enable us to have some good discussion. And that's about where I stop.